Here's another example, this one with slightly more interesting denominators. Our equation is 12 over x squared minus 9 plus 2 over x plus 3 equals x over 3 minus x. Well, because they're more complicated, we would want to look at the factorizations of these denominators to find their LCD. So I'm just going to rewrite this equation with factor denominators. 12 over, this is the difference of squares, x plus 3 times x minus 3. My second fraction, which I'm adding on, it would be 2 over x plus 3 doesn't factor, so I'll leave it in parentheses to emphasize that. And then my third fraction on the other side of the equation, my numerator is x. My denominator is not in descending order. That's a hint that there's a -1 factor because that sign of x is negative. So I'm going to take the -1 out at the same time I write it in descending order. So when I take a -1 out, the negative x becomes x, and then the positive 3 becomes minus 3. So let's create the common denominator now. The LCD is going to be the first denominator, x plus 3 times x minus 3. And then we're going to need anything from the second denominator that's not already there. But I already have x plus 3 in the LCD, so I don't need anything else. And then my third denominator has an x minus 3 in it, so we've got this. The other thing it has is a -1, but I want to remind you of something. This -1, when you have a fraction, can be written in one of three places. It can be written in the numerator, or the denominator, or out front. Right now it's in the denominator. I could actually not worry about adding anything into my LCD if I just move that -1 up top. So let's do that. Let's make this a negative x and eliminate it from down here. So that means my numerator is now going to be -x, and my denominator is going to be x minus 3. So I've just changed this problem a little bit. It's still the same equation, it's just that it's going to be much easier for me to work with and a simpler LCD if I move that negative to the numerator. And that's allowable with fractions. Now that I know what my LCD is, I'm going to multiply both sides of the equation by it. X plus 3 times x minus 3 over 1 times 12 over x plus 3 times x minus 3. Takes a little bit to write this out, just take your time, plus 2 over x plus 3 times x plus 3, the LCD, x minus 3 all over 1, so that's the LCD over 1, equals -x over x minus 3 times the LCD over 1, x plus 3 times x minus 3 all over 1. All right. What can we cancel here? Well, in the first term, we can cancel all of that denominator with all of the LCD because the LCD was the first fraction, or first fraction's denominator rather. So I get a 12 plus. In the next term, only the x plus 3 was common, and I can cancel it out. So I'm going to be left with 2 times x minus 3 in the numerator equals, and in my last fraction on the right side of the equation, I have x minus 3 that cancels, so I'm going to be left with -x times x plus 3. Fractions all gone, I just need to simplify both sides of the equation as the next step. So 12 plus distribute 2x minus 6 equals distribute the -x squared minus 3x. Notice through doing that distribution, I now see that I have an x squared term. That means I've got a quadratic equation. I should go ahead and move everything to one side. Let me simplify as I go. I'm just going to deal with this left-hand side first. So 2x, collecting like terms, 12 and 6, it's a -6 would give me 6, equals -x squared minus 3x. It's preferable to have this x squared be positive, so I'm going to move it to this side. So it'll be positive x squared. I'm going to move the -3x over at the same time, so I'm going to add it. 2x plus 3x is going to be 5x. And then I still have a 6 there. And that's equal to 0 because I've moved both terms away from the right-hand side and moved them to the left. Now I can factor this trinomial. X squared goes to x and x. the two factors of 6 that will make a positive 5 are positive 2 and positive 3. Now I can, using the zero product principle, set each factor equal to 0 and solve. So I'm going to get two solutions. I'm going to get x is equal to negative 2 and x is equal to negative 3. But remember, we need to check both of those. And I want to point out one thing. This x equals negative 3, if I were to put it back in, and it can sometimes be helpful to put it back into the factored form or just look at the factors. If I put it back into this denominator right here, that's going to make a 0 denominator. So this is actually not a solution. This is what we call an extraneous solution that comes up. Extraneous is a way of saying it's extra. It comes up because we were using this LCD technique. It's an extra solution that results from it, but it really doesn't work in the original equation. So we generally just cross it out. It's extraneous. Negative 2 doesn't make the denominator 0, so we're going to go ahead and check that. So let's plug that in all the way. 12 over, go back to the original equation, negative 2 squared minus 9 plus 2 over negative 2 plus 3 equals x over 3 minus a negative 2. Whoops, I forgot to put in my x in the numerator. I got so caught up with the denominators. So my numerator x should be a negative 2 as well. All right, so simplify the left and the right-hand side. So I've got 12 over 4 minus 9 plus 2 over 1. 12 over 4 minus 9 would be 12 over negative 5 plus 2 over 1. I need a common denominator to add it to the first fraction, so I'm going to write that as 10 over 5. 10 over 5 is the same thing as 2. Now, when you're working with a negative, again, with fractions, it's going to be better to make that negative go up top. So this is a negative 12 fifths plus 10 fifths, which when I add those numerators gives me negative 2 over 5. So my left-hand side is negative 2 fifths. Let's go back to the right side, negative 2 on the top. 3 minus a negative 2 ends up being positive 5, and that is exactly where we had the value we had on the left-hand side. So this does check. So again, it's very important that when you get solutions to these equations, you check to make sure your solutions do work. In many cases, you'll get this extraneous solution coming up, and you need to cross those out. They actually don't work in the original equation. So the only solution here, and I'll write this answer as solution set. The solution set is just the single value of negative 2.